My name is Jeff Nash. I'm from the University of Exeter. We've teamed with Chris Lawrence and colleagues at QinetiQ to look at new ways of controlling electromagnetic and acoustic radiation using a new generation of materials, including metamaterials and other systems. There are a broad range of applications for the type of techniques and technology we're developing. These range from using parts of the electromagnetic spectrum for applications in medicine and dentistry. We're also looking at new types of materials that would absorb radar for both defense and security applications. We're using these new materials to create new sources of light, particularly at wavelengths which are very hard to use conventional techniques. Applications include defense and security applications, but also gas sensing for atmospheric pollution.
QinetiQ's an international company. We work primarily on security and defence projects. My particular part of the company focuses on material solutions for things, smart materials, stealth materials, and trying to generate materials that adapt and control the flow of heat, light, ultraviolet and radio frequencies. So for example, we've developed thermal paints that help to hide people from thermal images, but equally they're applicable to make sure that you're comfortable in your car. We've got materials that will stop the heat from the engine going through to the cabin. We can develop packaging, and we have in the past, to keep ice cream colder for longer than is normally possible. And that's part of the fun, finding those links between the two and then learning from one and bringing it back to the other.
So in this lab we test and characterise a whole load of different devices, including those designed to emit and detect light at infrared wavelengths. So infrared light is incredibly important, but it's very hard to get hold of sources and detectors. It's light that we can't see with our eyes, but you can use it for applications such as gas sensing. So many important atmospheric pollutants, including CO2 and methane, have absorption wavelengths in the mid-infrared. And if you had suitable components and suitable devices, you could use those to sense these important gases and perhaps control their emissions. So one of the things we're incredibly excited about working with QinetiQ is how do we take the research that we've done on infrared sources and new generations of those and really take the devices from the laboratory into applications.
What we can bring to the university is the problems. So in some cases it isn't necessarily re-steering their research, but it's them recognising the value of what they've got, that they've got something that's thinner, lighter, less power requirements than what's already on the market. What we want to do with this project, though, is to try and develop something a bit more strategic, educate our staff, develop new ideas by understanding what the cutting edge of research is.
I think for me one of the most significant outputs actually is training a whole new generation of researchers who understand what it takes to take science and laboratory into engineering, into technology and out into UK PLC.
What we want to do is to try and develop something that's mutually beneficial, which is a culture of innovation and understanding what the problems are that need to be solved. So we're going to have postdocs and PhD students here working with the academic staff, but we're also going to have some based at QinetiQ. One of the things that excites me most about the project is that we're going to introduce our customers to this collaborative group of people. Working together, that's going to be a much stronger offering.
It's much more a vision than a project. It's an opportunity to really do something for the longer term, to create a partnership that is sustainable, that will produce new income, that will feed the science base and generally contribute to the prosperity of, particularly the South West and Exeter, but hopefully more generally the UK.